Hey everyone, in this video we are going to look at simplifying polynomials by combining like terms. This is just a quick review from last week's video. So the expression 2x plus 5 is an algebraic expression. 2x and 5 are called terms, and because we have two terms, it's referred to as a binomial. 2x, x in here is a variable, so it's referred to as a variable term. Variable just means letter. And when it's attached to a number, that number is then referred to as the coefficient. If you need some more review on that, please check out last week's video. And if you just have a number such as 5, that would just be referred to as a constant. Like terms and unlike terms. So like terms are terms that have the same variable and the same exponent. For example, we get a list of variables here. 3y squared, so we have a y squared and another y squared. So they're all like terms, okay? Because they have the same variable and same exponent. They're all to the power of 2. And unlike terms are terms that have different variables or different exponents. For example, you see this one is a y squared, whereas this one is a y. So they're not the same. And then this one is an x. So they're all unlike from one another. Now, what you see on your screen here is algebra tiles. And we can use these to represent polynomials. And in your book, your Math Makes Sense book, the dark colors represent a negative and the light colors represent a positive. Okay? And also in your book it indicates that the big squares are referred to as x squared. Okay, so this would be a negative x squared, positive x squared. The long rectangles are referred to as just an x. And the small squares are referred to constants, so just numbers without any variables. Okay, and we can use zero pairs to simplify our expressions, meaning that if you have these added together, they would cancel each other out. Okay, so if you have one of these, it would cancel like this one, because these are essentially opposites. It's like having a positive one and a negative one. All right. So if we were given some algebra tiles that looked like this, and we wanted to simplify it and write it as a polynomial, here's what we would do. We see our algebra tiles laid out like this. We are going to group them together. Okay, so you put all the like terms together. So this one looks a lot like this one, doesn't it? So we would just move this over. And as you can see, the 3's are grouped together and with this other positive constant here. Okay, so once we get them all grouped up in their like terms, we can start removing the zero pairs. Okay, so this one, black one here, this would represent a negative x. This would represent a positive x. So we could circle those, scratch them out, whatever you want to do. They cancel each other out. Okay, just as this white one cancels out this black one. So we can remove those. So what are we left with when we take this group and this group out of the equation? Well, we're left with this large one, this skinny one, and these two little black ones. Now we just have to ask ourselves, well, what do they represent? As identified in your book, this large square represents an x squared. So we would just say x squared plus an x. Okay, we don't need to say 1. It's always assumed that your coefficient is 1 when you're just given a variable. And then we say subtract 2 because black represents negative. Okay, so x squared plus x subtract 2 would be our simplified polynomial. So let's look at that again in a little more detail. We're given this set of algebra tiles. So we need to start canceling them out. I don't like to regroup them, I just like to cross them out. So I'll notice that these two are the same. They would cancel each other out. And I also notice that this black one will cancel out this white one. So what we're left with here is 2x minus 1. Okay? So that would be our simplified polynomial. If we look at the one down here, we notice that well, first we want to always remember that we write our polynomials in descending order is the preferred way to do it. I mean, it doesn't matter which order that the terms are in, but typically it's easier and well known that you go from highest exponent to lowest to constant. Okay, so we notice that we've got this big black one that would cancel out that white one over there. Okay, and we can go ahead and cancel out this one with one of these. So we cancel those out. And we see we've got two of these white ones, which we can cancel out with two of those. And what we're left with is negative x squared plus 3x minus 2. Okay, so how do we do this when we're not given the algebra tiles? Well, what we're going to do is identify the like terms. And this is just some examples I'll go through. We see that 2w is the same as w. Y is kind of the odd one out there. We've got an x squared there and an x squared there, so those will be like terms. As for y down here would be like terms. And also we've got y to the power of 3 here, so those would be considered like terms. In D, we've got an xy, which would be a like term here and a like term here. And at the bottom, 4x squared y is the same term as that y x squared. You can see that the x squared is written in different order here, but that doesn't matter. Okay, so we can simplify these polynomials by combining the like terms. So we're going to identify the like terms just like we did in those examples. We add or subtract the numbers, and we don't touch the variables. The variables remain the same. So what does that look like? So if you're given this polynomial, what we want to do here is group up our like terms. So we know that this a and this a can be grouped together, and this constant and this constant can be grouped together. Okay? So it's important to remember that when we identify the like terms, we're going to take the sign to the left with it. Okay? Now, once we arrange them, so all I've done here is just arrange this subtract 3 to be close to this 9 and group the 2 and the 5 together. And then I just work it out. So I just do my 9 subtract 3a, which is going to give me 6a, and then my 2 plus 5, which is going to give me 7. Okay? So all I'm going to be left with here, as you can see at the bottom of the screen, is 6a plus 7. Let's do another example. I see I've got my y squareds there, so I'm going to group those together first. Okay, so I just say 3y squared subtract 5y squared gives me negative 2y squared. And then I'm just left with my subtract y. There's no other like terms there, and there's no other like terms for my constant 6. So I just rewrite them. So I'm left with just negative 2y subtract y plus 6. Okay, that's it for this week, guys. If you need any more help, just come see me. Take care.